Yes, we shall start the module 4. We are going to start the module 4 we have started. In that, the new chapter called interprocess communication. See, the chapter name is interprocess communication. 572. Sorry. See, the chapter name is interprocess communication. Uh, See, in the previous class, we have discussed the execute function. See, the execute function, what it is to do is uh, from one process, it is going to communicate with the other process. Means the control will move from one process to the another process. The best way to communicate between the processes, the best way to communicate between the processes is the inter-process communication. One process will communicate with the other process. You can visualize like this. One process, it will send the data to the another process. Why it is required this inter-process communication? Why it is required is, the answer is, see, all the work, it cannot be done by a single process. It has to give some data to another process. The second process, it will do some task, and that process, it may communicate with another process, process 3, that will do some job, like that. That is why each process has to communicate. That is why this inter-process communication mechanism is required. Then, in order to support the inter-process communication, what is the technique? If one process has to communicate with other, what is the channel? How they are going to communicate? For that, the mechanism, the support is the concept called pipe. The pipe is one concept where you can perform the inter-process communication. The pipe is nothing but, why they have given the name is this pipe, because from one end we are going to write the data, from other end we are going to read the data from that pipe. Since this is the concept they have given, see, there are two ends. From one end there will be entry, from another end there will be exit. That is why they have given the name pipe. Yes, they have given this name called pipe. The pipe is just a mechanism. It supports inter-process communication where there is a transfer of data between the processes. What exactly in the system is file? It is just a pipe is nothing but a place or a memory, or it is a file where you are going to do some operations. This pipe operations, you are going to call it as some memory operations. That's all. The pipe operations, the name is pipe, but what actually in the background is a memory operation. From one end, you are going to write the data into the pipe. From other end, you are going to read, means that end should be identified. There should be address for that. There should be a unique address for those ends. If that unique address is not there, then how can you send the data to that pipe? That is why there will be a unique number for those. They are being called by the name called file descriptors. File descriptors. That is the name they are going to give it for the ends. One end, write end, other end, read. There is an array, there is a programmatical concept, but FD means file descriptor. Usually, where can you use the pipes? The normal pipes are there, and the another one is named pipes. See, if you are going to communicate, if the inter-process communication is between the related process means relatives. Who are the relatives? Parent and the child. They are the relatives. Yes. In this case, they can use these pipes. Whether there are unrelated process, whether they can communicate using these pipes, no, it is not possible. For unrelated process, there is another mechanism. They are called as named pipes. That is first in, first out. FI, FO. That is an example of a named pipes. That you have to use for unrelated processes. For related process, for ancestor processes, a process can communicate with its ancestors. Then that is called as this pipes, normal pipes. We don't use the word normal, it is just a pipes. Unrelated process they can communicate is with the named pipes. One example is first in, first out, FIFO pipes. I think you have seen the pipe symbol when you are using the shell commands what we have executed, cat space a file name, pipe symbol, wc count, means we have given one output of one command as an input to the other command. There we have used the symbol called pipe symbol. There exactly this is the concept it is being used. For every command there will be a process will be created. I think you have seen this command cat, some file name, then file name, then pipe symbol, then wc hyphen l. You can execute this command. It is going to give you the word count. Instead of executing two times, opening this file and then giving that output to this file, you can concatenate both these two using the concept called pipes. The shell, what it is going to do is if you execute this entire command, it will create one process for this command. It will create another process for the second command. The output of the first command, it will be passed to an, those two are related process, and the output of the first command, it will be given as an input to the other command. Means from one end of the pipe, the output will be written, the wc-l, it is going to read from that file and from that pipe, and it is going to execute. In this situation, how it is going to work? Two commands at a time in a single enter, how it will give the execution is in a single execution, how the two commands will give you the output is using this concept. In using these pipes, in one end, this output will be written and at the other end, it will be read. It is like this. Pipes, the name pipes, in the background, in the operating system, if you check, it is a memory operations. For both the ends, there should be a number. That is why there is a unique number that we are going to get that will be stored in the file descriptor array. There will be two file descript, one is for write, another one is for read. Even these pipes has limitations. What is this pipes limitation is? Half duplex. I think you have heard this word, half duplex and full duplex in computer networks. At a time, you can send only one side. There will be a communication from a parent to a child or to a child to parent. Both cannot communicate at same time. That is called half duplex. There are some Unix systems. There are some Unix systems. Unix system is nothing but the previous versions of Unix. They used to call it as ISOC. They used to call it as POSIX. Later, they have called it as Unix. Now Linux. That is the evolution. And in some of the Unix system, they support full duplex also, these pipes. And pipes can be used. What is the limitation? One limitation is half duplex. Most of the Unix system will be half duplex, and only few Unix systems it is a full duplex. And these pipes can communicate, can be used only between the process that have a common ancestor. Means it is between the parent and the child. Unrelated process, they cannot communicate. See how to create a pipe. You can create a pipe using a function called, in the library they have a function called pipe. They have a function called pipe. In which header file it is there? It is header file in uni.std. uni.std.h. In that header file, the body of that function is been written. What is the return type? Integer. Means if it is successful, it will return 0. If it has created a pipe, it is 0, or else it will give you -1. That indicates it's an error. The argument what you should pass to that pipe is an array of 2 elements. An array of 2 elements. That is the file descriptor. File descriptor of 0, file descriptor of 1. Why 2 values? One is for read, another one is for write. These two you can have to pass it as an argument. Int pipe of C, int file descriptor of 2 means for C, for 0 always it is for reading, and for 1 it is for writing. Remember that, and it is an array of 2 values. See, if you want to see one program, I'll show that. Say here, one program. What is there in this program is just 3 header files, and I have created an integer array of 2 elements. Process ID has been created, some character array, forget it. Pipe, see the pipe of FD. I have to give the array. As a programmer, I have to give the array of 2 elements, integer array. Then that integer array, it contains only 2 places. If the value, if it is less than 0, indicates it has not created a pipe. If it has not created a pipe, it will return value will be -1. That is why we are going to print it as pipe error. Or else, if it is successful, then the file descriptor, the pipe will be created, and the file descriptor is stored in FD of 0 and FD of 1. If you want to print that, printf, then we'll print that, sorry, percentage D, comma, FD of 0. See, FD of 0, that the first value will be the number of the read. Now we'll print the file descriptor number. Whether will it is able to print? Yes, the number is 6 and 6. Sorry, 6 and 7. 6 and 7. Okay. Because 2 times that parent and the child process both is going to run, right? That is why it is giving 2 times. The file descriptors are 6 and 7. See the numbers. For reading, the number which is given is 6. That is a unique number. In the system, in the computer, if you it is in the online compiler. If you check in the some other Unix operating system, it may give some other number. Yes. The next what we are going to do is, since this pipes, normal pipes, you can be used only with the relative processes, we are going to create a child process. Means that is why fork. We are doing the fork here. PID equals fork. If it is less than 0, we are going to print it as fork error. Or else, if PID is greater than 0, parent process. If PID equals 0, it is a child process. Two things. I think it is clear, the program. This is a parent process and this is a child process. Both the process will execute the entire program. Once you fork, the entire program will be executed by the parent ones and the child ones. Since this is a block here, this part, when it comes, the parent can execute only this block. The child can execute only this block. If the condition statements are there, based on those conditions only, the entire instructions will execute. Now, when the parent executes, usually what we are going to do is, we are going to close the unused ends. If the read end is not being used and we are doing some write operation, we are going to close the read. This is a programming practice because some other process should not interfere. Some other process should not interfere with this. That is why what we are going to do is, we are going to close the unused end. What we are doing here is, the parent, it is writing some message, hello world, or it is printing, hello child, how are you? See, what it is doing is, it is sending some message. From parent is sending some message to the child. What it is sending the message? Hello child, how are you? It is sending the message, how are you? See here, where it is going to write. Write is an built-in functions. Built-in function. There you are giving the file descriptor. Means FD1 is a write end. FD1 is write end. FD0 is read end. Here we are going to write. That is why we are going to close the read end first. Write, what is the pointer, means the file descriptor, what is the message, and what is the size of that array, that file. And we have sent the data to the one end of the pipe. When the child comes, close the FD1. Here we are going to read the data. Here we are going to read the data, but we are not writing it. That is why we are going to close the other end, close that file descriptor FD1 right end. Then inbuilt function read FD0. From FD0 you are going to read from that end. A line means it is an character array which is going to store what is being passed. It's a character array. See this line, it's a character array of 500. It is going to store whatever we are going to send. And what is the size of that? Maximum size. Some printf I have added child process. Write this, whatever you have got, write this into the standard output file name. Means to the standard output here is the console. Here the standard output file number is, it is going to write it to the console. Terminal ಗೆ write ಮಾಡುತ್ತೆ. ನೀವು ಇದೇ write function ಗೆ ಬೇರೆ FD1 FD0 ಅಂತ ಅಂದ್ರೆ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಫೈಲಿಗೆ ಹೋಗಿ write ಮಾಡುತ್ತೆ. ಅದೇ ಇದು ಟರ್ಮಿನಲ್ ಕನ್ಸೋಲ್ ಇಲ್ಲಿಗೆ ಬರಿಬೇಕು ಅಂತ ಅಂದ್ರೆ ದಿಸ್ ಎ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಔಟ್ಪುಟ್ ಅಂಡರ್ಸ್ಕೋರ್ ಫೈಲ್ ನಂಬರ್ ಅಂತ ಕೊಡ್ಬೇಕು ರೈಟ್ ಫಂಕ್ಷನ್ ಅಲ್ಲಿ. ಅವಾಗ ಇಲ್ಲಿ ಕನ್ಸೋಲಿಗೆ ಬರುತ್ತೆ ಔಟ್ಪುಟ್. That's why it is come to the output. This console means whatever the data is been passed, now we will run it. It's taking too much time. See, now you should get the output like this. Child process, this printf, hello child, how are you? That message it has to print. That's all. It's taking so much time. See, the output will be like this. The first it will be the child process. The child process, this order may vary because this child process can print first this message or directly the first one, the hello child, how are you? It is going to print, but this is going to be print here. This right from standard output. This is the line which is going to print it on the console. This is how you can send from parent to the child. This is how you are going to send from parent to the child. How? Using the pipes. Pipes, two array, sorry, array of two elements, and then from one end you write the data, from other end you read the data, and you can use it. See, you can visualize like this. If there is a communication between the pipe, the parent and the parent and the child, you can communicate like this. The parent will send the information to the pipe and this will be read by the child. If there is a half duplex, if it is a half duplex communication, then you can visualize like this. The child will send the, means it will write the data. It is going to write the data. See, the FT1 will write the data. The other end, we are going to read it from the parent and child. This is how you can visualize. In the background, this is how it works. See, one end of the is closed. These two rules will going to apply. What will happen in the background? If one end of the pipe is closed, that is what we'll do, right? First, we'll close the one end and we are going to write the something. And when we are reading the operation, we are going to close the right end. When we are writing, we'll close the read end. That is what we are going to do. If we read from the pipe whose right end has been closed, then the read will return 0 to indicate an end of the file after all the data has been read. It is going to return 0. In the same way, if we write to a pipe whose red end has been closed, then the signal SIG, this is a signals that is being generated. And that signals, it will be handled afterwards, whether to catch it or to return with a signal handler, that is left to the operating system. But the signal will be generated. This is one sample program just now which I have shown. The next thing in this chapter is the next function called p open and p close. The next topic is p open and p close. The p open and p close is nothing but pipe open and pipe close. But this why they have given this function is, as a programmers they used to do so many mistakes. What are the mistakes? They are not going to close the unused ends, and they are going to execute the shells to run the command. There are so many problems they used to create. That is why they are going to give you this flexibility of using p open and p close. If you just call this p open and you can pass the command string to execute, at the background itself it is going to create the fork and it is going to execute, functions will be called, and it is going to return you the file pointers. These things we are going to discuss in detail in the next class. This p open and p close. See, everyone, I'll request, please don't join to the meeting before 10:15. I have observed today also at 10:15 when I joined, already 23 to 24 members were there. This time problem will come into picture. See, already still it is 10:40, but already we have less than 1 minute. Okay. Please tomorrow, please join at proper time at 10:15. Means tomorrow at 9:30. Once I join, you can join. Okay. Thank you. We'll meet tomorrow. If you have sent the attendance, you can exit.